Greetings, young mathematicians. Let us now discuss the second algorithm in finding the shortest route in a given network. This is called the Floyd's algorithm. Now, compared with the Dijkstra's algorithm, we can say that Floyd's algorithm is more general, since in just one application, just one run of the algorithm, we can find the shortest routes, if there are any, if there is any, between any pair of nodes in the network. Unlike the Dijkstra's wherein a source node must be assumed. If we are to change the source node, you would have to complete or to apply the algorithm all over again. But its disadvantage is that we can only find one route per pair and no alternate routes are obtained, unlike the Dijkstra's. In the Dijkstra's algorithm, alternative routes are given for a given source node to a terminal node. Now, in the Floyd's algorithm, the key is the application of what we call the triple operation. But the idea is quite straightforward. Like, let's say, we have two nodes, say I, so suppose we have node I and node J. So suppose this is node I, and there is another node J here. If there is a direct route from node I to node J, meaning there is an arc existing with a distance d sub ij, this distance shall be first considered. So as the algorithm starts, the direct distances as considered as the shortest distance. But if there can be found another route from I to J which passes through another node, let's say K. So suppose there is a node here, let's say K, and the arc from I to K, let's say d sub ik, and then the arc from K to J is given by d sub kj. If it can be found that d sub ij is greater than d sub ik plus d sub kj, meaning if this is longer, if this path is longer than these two combined, that's the distance d sub ik plus d sub kj, then the direct distance or the direct route will be replaced by an indirect route. So instead of from I going straight to J, which was first considered, this direct route will be replaced by an indirect route from I. It passes through K, then before moving on to J. Okay, but again, if there can be found another route which passes through another node, let's say M here, M, where K, there is a distance or direct arc from K to M, so the distance is d sub km, and then there is a distance there from M to J with or given by or symbolized by d sub mj, and if it is found that this distance here, the sum d sub ik plus d sub kj is greater than the sum of these three, d sub ik plus d sub km d sub km plus d sub mj if it can be found that the sum of these three is less than these two, this distance that was found to be lesser than the direct will then be replaced by a more indirect path. Instead of ikj, it would then become ikmj. Again, if the sum of these distances, this one plus this one plus this one, is less than the sum of this one plus this one path. Okay, so that is the idea of the what we call the triple operation applied in Floyd's algorithm. So the algorithm makes use of two matrices, namely D and S. So the D matrix would tell us the shortest distance between any two pair of nodes in the network. Then the S is the matrix that would tell us the sequence of the nodes in the root. Okay, how the nodes are placed in a certain order so that you can move from one node to another. So the sequence node is represented by S, or the sequence matrix, and the distance matrix is by D. Okay, let us apply the algorithm directly in a particular example. So here we have a network showing us say five places in this node. The places are represented by the nodes, and then the arcs are the roads, and then the numbers on each arc will be represents the distance in miles, okay, of the two nodes connected by the given arc or road. So notice here that there is one branch or one arc here which is unidirectional, meaning this is a one-way traffic. So this road can be used only from 3 to 5 and not the other way around, not from 5 to 3. So but the other roads are two-way roads or two-way traffic. So to start with, we have step 0 or the initial step. So first we would have D sub 0 and S sub 0. Notice that there are numbers here at the leftmost side of the matrix, 1, 2, 3, 4, 5, and there are also numbers above the matrix 1, 2, 3, 4, 5. This represents the names of the nodes 1, 2, 3, 4, 5. So row 1 means from node 1, from node 2, from node 3. Then also the column have numbers. This would be the destination node to node 1, to node 2, to node 3, meaning this entry here represents the distance from 1 to 2. Okay, this entry. This one. That would be the distance from 1 to 2. Then the distance from 1 to 3 is 10 and so on. Okay, then as for the sequence matrix, still we'll have the rows labeled according to the nodes. Also the columns will be labeled according to the nodes. But you may see here that the number are just arranged 1, 2, 3, 4, 5 for each row. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 up to the last row, except for the entries in the main diagonal. Notice that the main diagonal is blank. The same is true for the distance matrix. Okay, so to put the entries on the distance matrix, we refer to the given network. So again, this entry here, we would try to magnify that. The entry here, for this number here, we have the distance from 1 to 2, and as we see in the given network, the distance from 1 to 2 is 3. So we put 3 on this entry for this slot of the matrix. 1 to 3, again row 1 to column 3, 1 to 3 is 10. So that would be 10. 1 to 4, but if we would refer to the network, there is no direct arc or direct branch from 1 to 4. So initially, we shall assume that the distance is infinite. Okay, so we put the infinity sign in the end or the entry for the first row, fourth column would be an infinity sign. The same is true for first row, fifth column, because there is no direct branch from 1 to 5 and so on. So we do the same for the rest of the entries in the matrix. Okay, so we see here that 3 to 5 is 15. 3 to 5 is 15. So in the entry for the third row, fifth column, we have here 15. But there is no direct road from 5 to 3 because this is a one-way road, 5 to 3. So that is why the distance or the entry for the fifth row, third column is infinite. Okay, because we cannot use 15 as the distance from 5 to 3. Okay, I hope you got that. Again, the sequence matrix S of O will just be the numbers from 1 to 5, or how many nodes, the given nodes. The number of rows and number of columns depends on how many nodes are there in the network. Since there are 5, so we name the rows 1 to 5 and the columns 1 to 5. Then the entries in the sequence matrix will just have the same arrangement as the column labels. So in this case, 1, 2, 3, 4, 5. Again, except for the diagonal of the matrix. Next, we highlight row 1 and column 1 of D sub O. Okay, so we will highlight the first row or mark. You can encircle the row or circle the column, or you can also use a highlighter. Okay, so we highlighted the first row and the first column. We shall call this the pivotal row and the pivotal column. Okay, so we may not highlight the entries or the rows and columns in the sequence matrix S of O, only for D. Then we apply the triple operation. We apply the triple operation on each entry of D sub O which are not contained in the pivotal row and pivotal column. So how do we apply the triple operation? Compare the entry, let's say this entry, the infinity. Compare this entry to the sum of the entries of the pivotal row and pivotal column, okay, that belongs to the same column and same row as the entry. Meaning for this entry, we look at the entry on the pivotal row with the same column as this entry here, so that would be 10, and the same row or the entry in the pivotal column which is in the same row as this entry, so that would be 3. So again, we compare this with this entry and this entry, the sum. So 10 plus 3 is 13. So infinity is assumed to be a very large number, meaning the sum 13 would be less than infinity. Meaning, this will be replaced by that lesser sum. So 10 plus 3 again is 13, which is less than infinity. So this is to be replaced. That is why we have marked this to indicate that this will be replaced in the next iteration. But for the next entry, we have 5. Compare 5 with infinity plus 3. Infinity plus 3 is infinity. But infinity again is greater than 5. So we do not replace 5. So we do not mark 5. Next is infinity. The entry that we are to compare this with is infinity plus 3. Infinity plus 3 is still infinity, only equal to the current distance here, infinity. So we do not replace this entry yet. So for the second row, one entry will be replaced in the next iteration. For the third row, we start with this entry here because 10 is on the or in the pivotal row, pivotal column rather. So we would not change that. Okay, that would be just serve as the basis for whether we change the entry or not. So we compare it with 3 plus 10. Okay, 3 plus 10 is 13, less than infinity. So, this would be replaced by 13 in the next iteration. 6 will be compared with infinity plus 10. Infinity plus 10 is infinity greater than 6. 15 will be compared with infinity plus 10, which is also infinity greater than 15. So, this entry will be, for this row, this entry will be replaced in the next iteration or the next step. Now, for row 4, we compare 5 with 3 plus infinity, which is infinity greater than 5. 6 with 10 plus infinity, which is infinity greater than 6. Infinity plus infinity would still be infinity, which is greater than 4. So, no entry will be replaced in row 4. For row 5, we have infinity compared with infinity plus 3, which is infinity equal to the current entry. Next, same infinity will be will be compared with 10 plus infinity. That would still be infinity. So, equal to the current entry. 4 is to be compared with infinity plus another infinity. So, the sum is infinity greater than 4. So, no entry will be replaced in row 5. Next, we mark the same entry or the entries in the same position in S of O. So this is the entry on the second row, third column. Second row, third column in S is this entry. So we also mark that. This is also marked. That is the entry in the third row, second column. So third row, second column in S is also marked. Next, we proceed to the next iteration. The next iteration, we simply copy everything except for the marked entries. Those that we have marked will now be replaced in the next iteration. Okay. So you see here, D sub O is now D sub 1 in iteration 1. We copied everything except for these two entries here. These two entries are now replaced by these red entries. I marked it red or I wrote it red so that we would notice that they were changed. So again, infinity will be replaced by 10 plus 3. So that is why we have here 13. The same is true for this entry. Okay, 3 plus 10 is 13 also. So this is now also 13. As for S, this will be replaced by the column or the row number that were highlighted. So we have highlighted here row 1 or column 1. So these numbers, this entry in S will be replaced by 1. Okay, so we see it here. Notice that they are both 1 this time. Then we again apply, or by this time we na-highlight the second row and the second column. They are the new pivotal row and pivotal column. Okay, this time second row, second column. Then we apply the triple operation to all entries not contained in this row and column. Okay, so second row is highlighted, so the other entries in the first row are not highlighted, meaning they are now to be applied with the triple operation. Okay, so we apply the triple operation on the first row, third, fourth, and fifth rows. Okay, first column, third, fourth, and fifth columns. So starting with 10. 10 is to be compared with 13 plus 3. 13 plus 3 is 16. But 16 is greater than 10, so we do not replace 10. Infinity will be compared with 5 plus 3. 5 plus 3 is 8. 8 is less than infinity, so this entry will be replaced in the next iteration. Next, we have infinity. Infinity compared with 3 plus infinity is still infinity, so equal to this entry, so we do not replace that. Then we proceed to the third row. 3 plus 13 is 16, greater than 10, so we do not replace 10. Next entry is 6. Compare that with 13 and 5. Here, 13 and 5. 13 plus 5 is 18. 18 is greater than 6, so we do not replace 6. Next entry, 15. Compare 15 with 13 plus infinity, which is infinity, greater than any number. So it's greater than 15, so we do not replace 15. Next, in the fourth row, we have infinity to be compared with 3 plus 5. 3 plus 5 is 8, which is less than infinity. So we mark it, meaning it will be replaced in the next iteration. Next, we have 6. 6 is compared with 13 and 5. 13 plus 5 is 18, greater than 6, so we do not mark 6. Then 4 compared with infinity plus 5. Infinity plus 5 is infinity. Okay, greater than 4. Next, we have infinity compared with infinity plus 3. The sum is infinity, equal to the current entry. Next entry is infinity, all still. Infinity plus 13 is infinity, only equal to the current entry. Next is 4. 4 compared with infinity plus 5, which is infinity, greater than 4. So we mark two entries. That of on the fourth row, first column, and first row, fourth column. So the same entries are marked in S sub 1. Then we move on to the next iteration. We now construct D sub 2 and D sub S sub 2. D sub 2 and S sub 2. Now, for D sub 2, copy everything from D sub 1 except for those marked entries. So take note that we have marked this entry and this one. So we shall change that, replace that with the sum of the entries in the pivotal row and pivotal column. So for this entry, that will be replaced by 3 plus 5. So it becomes 8 in the next iteration. So this would also become 8 because 3 plus 5 is also 8. Okay, so these marked red entries here are the replacements of the marked entries in D sub 1. But for S sub 2, we simply copy S sub 1, copy this, except for the marked entries, this entry and this entry. So those will be replaced by this time 2 because we have highlighted the second row, second column. So these two entries will now become 2 in the next iteration. So see here, the first two entries were replaced by 1 in our first iteration, but this time these two entries will now be replaced by 2. This is now 2 and the other entry is also 2. Then highlight this time the third row and the third column for our pivotal row, pivotal column. Then again apply the triple operation to the rest of the entries in the matrix D sub 2. Same process. Starting with 3. 3 to be compared with 13 plus 10 is 23. So greater than 3. So we will not mark this. 8 compared with 10 and 6. 10 plus 6 is 16. Greater than 8. So we do not mark 8. Next, 10 plus 15. 10 plus 15 is 25. Less than infinity. So we now mark infinity in the first row. Second row, 3 is compared with 10 plus 13. Again, 23 greater than 3. Next, 5. Compare it with 13 plus 6. 13 plus 6 is 19. Greater than 5. Next is infinity. Compare it with 13 and 15. That is 28. Less than infinity. So we also mark this entry. For the fourth row, 8. 8 compare with 10 plus 16, 10 plus 6, 16 less than 8. 8 is less than 16, or 16 is greater than 8. So we do not mark 8. Next, compare 5 with 13 plus 6, 19. But 19 is greater than 5. 4. 4 is compared with 15 plus 6. 15 plus 6 is 21, greater than 4. Next entry in the fifth row, infinity. But take note, infinity, the entry in the pivotal column is already infinity, meaning no matter what we add to infinity, the sum would still be infinity, and it would be greater or equal to any entry in row 5. So no entry in row 5 will be replaced. Only 2 entries are marked. So we mark the entry in the same position in S sub 2. Then we proceed to iteration 3, where we construct D sub 3. So these marked entries here will now be replaced. This one will be replaced by 10 plus 15. So that will be 25. This one will be replaced by 13 plus 15. So that is 28. Okay, then these two entries will be replaced by 3. Okay, so these are now 3 here. Next, mark the fourth row and fourth column as our pivotal row and pivotal column. Then apply again the same process, the triple operation to the rest of the entries. 3, compare that with 5 plus 8. 5 plus 8 is 13, greater than 3. 10 compare with 8 plus 6. 8 plus 6 is 14, greater than 10. Then 25. Note that 25 is a new entry, but still it will be applied with the triple operation. No exemption except for the pivotal row and pivotal column. So 25 will be compared with 8 plus 4. 8 plus 4 is 12. But 12 is less than 25. So even if 25 is a new entry, it will be replaced in the next iteration because the sum of the entries in the pivotal row and pivotal column is less than that entry 25. So this is marked. Next, 3 compared with 8 plus 5, 13 greater. 13, compare that with 5 plus 6, 11. 11 is less than 13, so we mark 13, meaning it will be replaced in the next iteration. Next is 28. 28 compared with 5 and 4. 5 plus 4 is 9. 9 is less than 28. Next, we have 10. Compare that with 6 plus 8, 14. 14 is greater than 10, so we do not replace 10. 13. Compare 13 with 5 plus 6. 5 plus 6 is 11. Less than 13. So we are to replace 13 by 11 the next iteration. Next is 15. 15 compared with 6 plus 4. 6 plus 4 is 10. Less than 15. So we'll replace that one. Next, infinity. Compare that with 8 plus 4. 12 less than infinity. Next infinity is compared with 5 plus 4. 5 plus 4 is 9. So that is less than infinity. So we are to replace this. Next entry is this infinity. Compare that with 6 plus 4. 6 plus 4 is 10. Less than infinity. So we are to replace how many entries? 1, 2, 3, 4, 5, 6, 7, 8 entries in the sub 3. So we also mark the entries in the same position in S sub 3. But this will be replaced, this entry in S sub 3 will be replaced by 4 in the next iteration. Then this will be replaced by the corresponding sum. So we have D sub 4. Okay. So again, for D sub 4, simply copy D sub 5. But this time replace the entries that we have marked. So for example, this will become 12. This will be 25 becomes 12, 13 becomes 11, 28 becomes 9, 13 becomes 11, and so on. These entries will become 4 in the next iteration. So in S sub 4 and D sub 4, these are the new entries. Here, the red entries. Okay, so the green, those entries marked green are now replaced by the sum of the entries in the pivotal row, pivotal column. Next, we highlight the 5th row and the 5th column. These are now the pivotal row and pivotal column. Then we apply again the triple operation to the rest of the entries. So 3 compared with 9 plus 14. 9 plus 14 is 23. Way greater than 3. So we do not replace 3 anymore. 10 be compared with 10 plus 14. 10 plus 14 is 24. Greater than 10. Again, we replace only if the sum is less. But if the sum is equal or greater, we do not replace the current entry. Okay, so we simply apply the same process to the rest. We would know that no entries will be replaced in D sub 4, implying that no entries will also be replaced in S sub 4. Hence, the entries in D sub 5 will just be the same as those of D sub 4, and the same is true with S sub 5. Entries for S sub 5 will be the same as those in S sub 4. Since all rows and columns have been highlighted already, there would be no more pivotal row and pivotal column in iteration 5. Therefore, the number of iterations in the algorithm will depend on how many nodes are there in the network. Since there are 5 nodes, then we should be up to iteration 5. Okay, so we end at iteration 5. Therefore, we have the final matrices. The distance matrix is D sub 5. The node sequence matrix is S sub 5. So, how do we answer the question? If we go back to the instruction, we were instructed to find no particular pair. Okay. We'll just consider any pair. Anyway, we can determine the shortest routes between any pair of nodes in the network. So suppose we are to look for the shortest route from node 2 to node 5. Node 2 to node 5. If we look at the distance matrix, D sub 5, node 2 to node 5 meaning row 2, column 5. Row 2, column 5 is 9 in the distance matrix. Meaning the shortest distance from node 2 to node 5 is 9 miles. Okay, because the distances were given in miles. This is the shortest distance. Now, where do you proceed from 2 to 5? What is the sequence? So we write 2 and with 5. Then as for the intermediate node between 2 and 5, we look at S sub 5. S sub 5 or the final node sequence matrix. So we look at the second row, 5th column. Notice that the entry is 4. Meaning, between 2 and 5, there is a node 4. Then, to determine what is between 4 and 5, look at row 4, column 5 in the final node sequence matrix. Row 4, column 5. Row 4, column 5. Notice there is 5, meaning 5 is between 4 and 5. In other words, 5 is already 5, so no intermediate node between 4 and 5. So 4 directly goes to 5, or the root is from 4 directly to 5. Okay, so we now have an arrow here. Next, we determine what is between 2 and 4. So we look at the entry of row 2, column 4. Row 2, column 4, that is 4. So already 4. So the root would just be from 2 directly to 4. Meaning, the shortest distance of 9 will be obtained if we follow the root. From 2 we go to 4, then from 4 we go to 5. Let us check that. 2, then 4, then 5. From 2 go to 4, then from 4 to 5, the total distance there is 9 indeed. Okay, let's try another. So suppose we are to look for the shortest route from 5 to 1. 5 to 1. So based on the distance matrix, the shortest distance from 5 to 1, meaning row 5, column 1 is 12. Okay, 12. But what is the root? What would be the arrangement of the nodes? So start with 5 and with 1. Look at row 5, column 1. Row 5, column 1. In this sequence matrix, row 5, column 1, we have 4. So node 4 is between 5 and 1. So we put 4 here, between 5 and 1. Then proceed to looking for the intermediate node between 4 and 1. 4 and 1. So row 4, column 1. Row 4, column 1 is 2. So meaning there is 2 between 4 and 1. Next, determine the entry between 2 and 1. Between 2 and 1, the entry is 1. Meaning, from 2, you move directly to 1. Next, determine the entry between 4 and 2. Between 4 and 2. So that will be row 4. Row 4, column 2. That is 2. So, we move directly from 4 to 2 because the intermediate node there is 2. So, there are already arrows here indicating that that would be the parts of the root. Next, what is intermediate? What is between 5 and 4? So, look at the entry in row 5, column 4. Row 5, column 4 is 4. 4. So the 4 is between 5 and 4, but 4 is already the end node here, or terminal node. So there is no node between 5 and 4. Hence, we have determined the shortest route from 5 to 1. That is moving from 5, then 4, 4 to 2, then 2 to 1. That distance again would give us 12. Let us check. 5, 4, 2, 1. So from 5, go to 4. Distance is 4, then 2. So it will give us 9. Then 2 to 1, 3. So indeed, the distance, total distance is 12. Okay. So the next activity in this lesson is similar to this example. The answer key is already given in the module. So I would just leave that up to you. And the learning task is just quite similar to this. So I would be expecting you to submit your answers to the learning task before the year ends. But in case you don't have time, I would still be waiting until next year. So that would be all for this lesson. Thank you for listening. I hope you would not get tired of watching our video lecture in any of the subjects this semester that I handle. Okay, again, thank you for your attention. And good luck and goodbye. Happy Merry Christmas and have a wonderful New Year.